Okay, this is part 135, line 18A, neutrino split decay muon quarks mesons 5G UFO formulas. Wow Seti. There we go. There's the keywords. Here's our formulas coming up. There's the Wow Seti alien radio signal that I found. And that's the Google number that I used to get this information. Google neutrinos transfer energy to muon. I wanted to see if neutrinos could do that. And this came up. We can only detect the presence of a neutrino in our experiment if it interacts. Neutrinos interact in two ways. A charged current interaction where the neutrino converts into the equivalent charged lepton. Inverse decay. There's the calculations there. The experiment detects the charged lepton. Neutral current interactions where the neutrino remains a neutrino but transfers energy and momentum to whatever it interacted with. We detect this energy transfer either because the target recoils, neutrino-electron scattering, or because it breaks up. And there's the calculations for that. And they are at t2kexperiment.org. They've been experimenting on neutrinos. My thoughts continued February 17, 2012. And for some reason, this is too small. There we go. Okay. So we need a charged current interaction. So can the turbine invention send a laser beam to the neutrinos to charge them into the equivalent charged leptons, or inverse beta decay, VE, and neutron-electron scattering? Those are the two things we want to do. Since atoms split and join other particles, using a moderator with the neutrino-electron scattering, can you slow it down so it doesn't break up, but instead splits in half and doubles the power? Let's see if anyone's split a neutrino. So I looked it up, and here's a graph here showing muon decay. So the stationary muon suddenly decays into electron and neutrinos. Left. If hypothetically during muon decay only one neutrino were created, then since the total energy released is always the same and momentum always needs to be balanced, the electron, the only thing we see, would always be ejected at the same speed. Right. In particle, we see the newly created electron ejected at a wide variety of speeds. It takes a bit of analysis, but what we see is consistent with the creation of two unseen particles. And this I got from www.askmathematician.com. So I googled the split neutrino and I got this paper up. The neutrino spectral split in core collapse supernova, a magnetic resonance phenomena by Sebastien Galais and Cristina Volpe. A variety of neutrino flavor conversion phenomena occur in core collapse supernova due to the large neutrino density close to the neutrino sphere and the importance of the neutrino-neutrino interaction. Three different regimes have been identified so far, usually called the synchronization, the bipolar oscillations, and the spectral split. Using the formalization of polarization vectors within two flavors, we focus on the spectral split phenomena, and we show for the first time that the physical mechanism underlying the neutrino spectral split is a magnetic resonance phenomenon. In particular, we show that the precision frequencies fulfill the magnetic resonance conditions. Our numerical calculations show that the neutrino energies and the location at which the resonance takes place in the supernova coincide well with the neutrino energies at which a spectral swap occurs. The corresponding adiabaticity parameters present spikes at the resonance location. And that's solar and stellar astrophysics, high energy physics, phenomenology, submission history, March 2011. It's pretty new. So you want to go to arxiv.org and look up that document. And it's arxiv 1103.5302v2. Okay. Here's another graph here. This is induced beta decay. An electron-neutron can cause a neutron to turn into a proton. An electron. A muon neutrino would create a proton and a muon. The antineutrinos can induce a reverse beta decay where a proton is turned into a neutron and an anti-electron, or anti-muon, or anti-muon. And that's askthemathematician.com. So the next thing I googled was magnetic resonance phenomena. And this is what came up. Acupunct electromagnetic resonance phenomena as a possible mechanism related to the bidigital O-ring test molecular identification and localization method. Abstract. The author hypothesizes, so it's a thought, that the mechanism of the bidigital O-ring test molecular identification and localization method is due to electromagnetic wave resonance phenomena between two identical substances having an identical resonance frequency and separated by a known distance. Such a hypothesis was tested and proved by using two identical sets of electromagnetic resonance circuits, each consisting of a fixed inductance L and variable capacitance C in the place of two identical substances or molecules. When one of the resonance circuits was connected or placed close to the body surface, and when the frequency of the other resonance circuit was made identical to the one placed next to the body, a maximal weakening response of the bidigital O-ring test was observed. Only when the axis of the coils of the two separate sets of resonance circuits were oriented perpendicular to each other, when the axis of the coils of the two separate sets of resonance circuits were oriented parallel to each other, no bidigital O-ring test weakening response was observed, even when both resonance circuits had an identical resonance frequency. The information about the molecular structure and quantity of any molecule is contained in the specific electromagnetic field emitted by the particular molecule. These electromagnetic waves containing information about the particular substance can be propagated through a metal wire, through a concentrated electromagnetic field projector, or through a light beam with wavelength longer than green color, particularly a monochromatic collimated light beam or soft laser beam. In the cases in which a light beam is used, the monochromatic light beam, including laser beams, acts as a very high frequency carrier of the electromagnetic waves emitted from a particular substance placed near the source of the light beam or near the end of the light beam. And the information on the molecular structure and amount of this substance is carried by the light beam, including the amount of substance carried by the light beam, including laser beam, in both forward and backward directions, bidirectional propagation of information. Again, this is important because I talk about a light beam and a laser beam being used for a space elevator that I'll be showing you in the future, and that's in line 18A OPQR, and also in other videos. And also we'll be using a light beam and a laser beam to generate speed with the neutrinos and the cold plasma argon gas mixture that I've hypothetically posted on the video. Even reflected from any molecule or substance is in the visual field that reaches the eyes carries information on the substance to the eye ground, particularly when the individual is gazing at the substance. Simultaneously, information on a substance not normally existing in the body that happens to be in the body is sent out from the eye ground in electromagnetic waves to the object being gazed at by the individual. And that was 2879416, and that's at www.ncbi.nlm.nih.government. So here's a graph here to look at. And this is distribution of mass for the combination of pi and XC1 meson. The peaks at 4050 MeV and 4250 MeV correspond to the Z1 and Z2 particles. That's from the CERNcourier.com. Again, this is CERN testing is coming up in the data. And this mass of the known Y55 particle. And there's that. And that. Measured production rate of an upsilon and two pions as a function of the collision energy of the E plus and E minus beams. The production rate peaks at 10,890 MeV for all three types of Upsilon mesons, 1s blue, 2s red, 3s green, and the dashed red line is massive YS5. It's CERNcourier.com 36278. February 17th, my thoughts. The keywords here is Y and beam. Upsilon mesons, 4 quarks. Now I said the neutrinos divided up into 4 quarks, and you couldn't see them during your testing. That's what I think would happen. I'll try to prove it to you. But I honestly think neutrinos do divide when you collide them. They can divide into 4 quarks. I would look to see if there are Y5s particles are the same as neutrinos. I'm not sure if it's the same particle or if it's different. And maybe they've given them a different name in Japan than in North America. I just assumed because this was tested. It's just, yeah. So, something you can look at. Here's another graph here that I found. It'll explain. The explanation for the deficit in neutrinos is now called neutrino oscillation. In the theory of neutrino oscillation, these solar neutrinos are electron neutrinos, and in their passage to the Earth, they change form and become muon neutrinos or tau neutrinos. It will be better if we follow convention and split the neutrino emission and absorption by putting a W boson between the quarks and leptons. And that's from carlbrannan.wordpress.com. He's a blogger. And this is the stuff he's written here. And I did highlight it for myself. Now the problem with all this was the number of neutrinos being detected on the right did not seem to equal the number of neutrinos that we've pretty much known to be emitted on the left. Something was happening to them. I was talking about the fact that half of them split in half and the other half split into 4. I haven't figured out why though. According to the latest Wikipedia data, the VUD entry for CKM matrix is 0.97383. It's an amplitude, so to get a probability we have to square it. The resulting probability for the down quark is about 94.83%, so this isn't much of a cause for a neutrino deficit. And as I mentioned above, this doesn't matter anyway. A higher generation quark would just decay down to the D anyway. Again, this is carlbrannan.wordpress.com. He's a blogger, and I believe he's a physicist as well. He's into the world of physics. And my stuff seems to be all scattered around here. So I did the 0.97383 times the speed of light equals 291,946,889 miles per second. Okay, because I wanted to see how fast that was. My thoughts, February 17th, 2012. At 5:18 p.m. Based on the results of this experiment, what if the neutrinos split and divided into 2 smaller particles, or even 4, so that they could not be detected because our particle reactors cannot detect something that small? Quote, when an up quark emits a W plus boson, it can turn into other quarks than just the down quark. Electric charge has to be conserved so that other possible quarks beside the down with charges minus 1/3 are the strange and bottom. Now over the long term, since the strange and bottom quarks weigh more than the up quark, the interaction will end up with just the down quark. The strange and bottom quarks will convert to a down quark or be reabsorbed or do something cool. But on a short enough time scale, any of the down quarks DSB can end up created along with the W+. Like anything in quantum mechanics, there are different probabilities of these things happening. And like anything in quantum mechanics, there are different phases which can cause interference. Our sum total knowledge of what happens in this interaction is held in the Kobayashi Masakawa or CKM matrix. Sorry if I said it wrong. Again, that's carlbrannan.wordpress.com. I'm quoting what he's posted about neutron oscillation or interference. Okay, so the entries of the matrix specify an up type quark, UCT, and a down type quark, DSP. It has 3 times 3 equals 9 entries running from UD to TB. Each entry XY defines the amplitude that when a W plus emitted by an X quark with charge plus 2/3, the resulting quark with minus 1/3 will be the Y quark. Now, I'm very interested in the Y quark because one of the alien formulas that I posted, the mathematical equation, back, I think it was 17TB2. It had a y in it to the power of y, so I was wondering if it had something to do with this. And again, another article that I found, CERN Courier, October 20, 2008, Bell finds more exotic mesons. The Bell collaboration has announced the discovery at the Japanese beef factory KEKB of 3 new exotic subatomic particles, which they have labeled the Z1, Z2, and YB. The Z1 and Z2 states appear to be particles consisting of 4 quarks, while the YB may be the first clear example of an exotic hybrid particle, containing an excited gluon in addition to a quark-antiquark pair. So if we have an excited gluon, we can use this YB in our formulation as well. So we have 2 new particles with the red line and without the new particles, the blue line. Okay? Figure 1. In the past few years, a number of peculiar new particles, including the X3, there's the different numbers for them. This is peculiar. They have been found both at Bell and at the Babar experiment at SLAC. So these are new particles that they found. Last year, the Bell team reported the first exotic particles containing A, C, and C quark with non-zero electric charge. Z. Again, that's in the Courier. It was posted 2005 and February 2008 on page 7. The Bell collaboration has now found further new particles stated in the decay products of B mesons produced at KEKB. The team searched for states decaying into a pi and XC1. Again, if you remember back, I keep interrupting here, right? But pi comes up a lot in the Wow Seti data as well. So anything with anything, any keyword, I always look at it and say, well, maybe we can use this, okay? A well-known Charmonium meson and found mass peaks that, if anybody can explain these speeds to me, I would really appreciate it. I don't know what 4051 MeV means, or how fast that is, or what it's used for, okay? So if you are watching this video, you can actually tell us what this MeV thing is. I'd really appreciate it. I tried Googling it, and I didn't get very far, so which they have named the Z1 and Z2 respectively. The states have non-zero electric charge and could be further examples of particles consisting of 4 quarks. A, C, and C bound together with a quark and different antiquark, as in CuCd, for example. Okay, YB state was found in a different way in an energy scan of the KEKB accelerator, where the Bell team observed a dramatic increase in the production rate of the upsilon together with 2 pions at an energy of 10,890 MeV. I wonder if we can use that for the spaceship. This indicates the production of a new particle decaying into upsilon and 2 pions. This could be the first example of an exotic bodomonium particle consisting of a bound state of a B and B together with an excited gluon, although there are other possible interpretations, and it gives you some further readings there. And that's on the CERN Courier. Okay, since the neutrinos were produced for an extremely high energy reaction, they carry quite a punch. This is again a quote. The particles resulting from the interaction move fast enough through the water in the detector, and they form Cherenkov radiation, which is essentially a sonic boom made of light, or the result of it at least. By looking at how the boom hits the light sensors around the detector, you can get energy and direction information about the original particle. So then I looked up Cherenkov radiation. It's an electromagnetic radiation emitted when a charged particle, such as an electron, passes through a dielectric medium at a speed greater than the phase velocity of light. Okay. Okay, so that was on the Cherenkov radiation on Wiki. And then astrophysics experiments when a high energy TeV, gamma photon, or cosmic ray interacts with the Earth's atmosphere. It may produce electron-positron pair with enormous velocities. Again, these are keywords that are very important because we want to create enormous velocities and we want to create high energy. So, particle physics experiments. Cherenkov radiation is commonly used in experimental particle physics for particle identification. One can measure or put limits on the velocity, again a keyword, of an electrically charged elementary particle by the properties of the Cherenkov light it emits in a certain medium. If the momentum of the particle is measured independently, One could compute the mass of the particle by its momentum and velocity. See for momentum and hence identify the particle. The simplest type of particle identification device based on Cherkov radiation technique is the threshold counter, which gives an answer as to whether the velocity of a charged particle is lower or higher than a certain value. And that's that calculation, where c is the speed of light and n is the refractive index of the medium. By looking at whether this particle does or does not emit light is a certain medium, let's bypass that. Then we have a rich detector that comes up, and it talks about high-speed charged particles. Transverse is a suitable gaseous or liquid medium, often called radiator. This light cone is detected on a position-sensitive planar photon detector, which allows reconstructing a ring or disk. Okay, it's a detector. It's used to create photons. Sorry. I seem to be losing my voice. Okay, my thoughts. February 17th. You can take the formulas I've provided and see if you can split the neutrinos into 4 quarks, which seems to be the case in your experiments. Thus, we technically have 4 times the power of 1 neutrino if this is the case. What kind of velocity do you think that could create? 4 times the speed of light is that number. Now take this equation and figure out with your mathematical functions how fast you would arrive at Mars with this type of UFO engine speed. Okay, I'm losing time here, so I don't know if we'll get through this or not. It'll be in the next video if I don't get all the way. I have no idea how to do that. Do you? Let us know. This means that when Earth and Mars are closest to each other, the distance would be... Okay, so there's a calculation of Earth and Mars, and I got a quote from Athena. So then I did some calculations, and I took the speed that we need to do, and we can get there in 2 months, and I wanted to get there in 3 days. So you'd have to split the neutrinos 5 times in order to make it 20 times altogether to get there in 3 days to Mars. And here's some tags. Okay. And this video is out of power. So there's the numbers again that I did. This will be